Hello friends, welcome back to my YouTube channel. Today we will be discussing some important questions from 2016 October-November paper. Now let us see our first question. In this question, it is asked that which is magnitude of Young's modulus of copper. Generally, magnitude of Young's modulus is in the order of 10 to the power 11. So 10 to the power 11 Pascal is the unit of Young's modulus. So option choice D is the correct answer. Now let us see question number 2. The force between 2 point charge Q1 and Q2 at a distance r is given by the expression F is equal to K Q1 Q2 by r square. Here we need to find the SI base unit of K. For this we should know the SI base unit of F, R and Q. F is Newton is kg meter per second square. R is a meter, r square is there because of that meter square. We know that SI base unit of Q is equal to I into T, because I is equal to Q by T. Current is rate of flow of charge, and coulomb is not a SI base unit. Now I will convert coulomb into ampere second. So I will write in the place of Q I will write ampere second, and on doing this calculation, on doing writing unit of all and doing calculation, we will get our answer B. Option choice B is the correct answer for the question number 2. Now let us see question number 3. In this question, aeroplane can fly with a velocity x when it is in still air, and it can fly in the wind. The aeroplane's velocity relative to ground is y. It means that the velocity x of the aeroplane is now affected by wind. The velocity of wind is w, and the result of x and w is y, because y is the relative velocity of the velocity of plane in the presence of wind. So y is the result of x plus w. So x plus w should give us y. Now if you see the vector diagram, then our formula for triangle law is x is pointing in this direction, y is pointing in this direction, and y is just opposite to that. They are in the same pattern, and this is it opposite pattern, and they are making a close figure. It means that x plus w is equal to y. So option choice A is the correct answer. Now let us see other questions, other options. In this part, if you see this arrow, this is w plus y is giving x, which is in fact not correct. Here in this question, x plus y is giving w, that is also incorrect. In this question, this w plus y is giving x, this is also incorrect. So option choice A is the correct. In this question, we need to see the diagram, vector diagram. Vector diagram is if the two vectors are in the same pattern and another one is in the opposite order, and they are making a close figure, means this third gives the resultant of the first two vector. That is in option choice A. So option choice A is the correct answer. Now let us see question number 4. Here in this question, this is true value and this is the voltmeter reading value. Now according to this question, the the voltmeter reading is larger than the true value. If we see the diagram first, here the voltmeter true value is this, and the reading will be this, and in the 2 also it will be this. It means that if the true voltmeter reading is 1, then meter reading is more than 1. If the true reading is 2, then the voltmeter reading is more than 2. In option choice B is also, if the true reading is 1, then this is just more than 1. But if you see option choice C and D, when true reading is 1, the meter reading is less than 1. Meter reading here also is less than 1. Because of that, option choice C and D cannot be our answer. Now let us see option choice A and B, and let us note this term. The systematic error also varies with voltage. This is the reading here. This is the systematic error here. When the true reading is 0, then there is already some reading in meter reading. So this is error. And if you see this diagram, B, option choice B, for the value 1, for the true value 1, there is certain meter reading here, and for the value 2 there is also certain meter reading here, but they are same, they are not increasing. It means that the systematic error is not increasing here. But if you see option choice A, here is some certain systematic error at the beginning when the true voltage reading was 0. but when the true voltage reading is 1, the error is now increased, and here also it became more, and here it is again increasing. Because of that, the point are moving so far from the actual curve, then this gap is becoming more and more. Because of that, option choice A is the correct answer for this question, option choice A. Now let us move to question number 5. In this question, we need to find the time period of the signal. Here it is given that 5 millisecond per centimeter, it is the time based reading, and the total distance is 10 centimeter. Now if you see this, this one crest and one trough makes one complete wave. So if we mark this point, then time taken for this point is capital T, that is the time period of a wave, and it will be 2t, it will be thrice t, and this part will make it 3.5 t. So 3.5 t is equal to 10 centimeter. So only t or 1 t will be 2.85 centimeter. Then question is giving sorry, then question is giving the time based setting that 1 centimeter is equal to 5 millisecond. So on multiplying this by 5 millisecond, that is 5 into 10 to the power minus 3 second, we will get our answer. Answer is 1.4 into 10 to the power minus 2. That is in option choice D. So option choice D is the correct answer for the question number 5. Here we got capital T in the term of centimeter from figure, and on multiplying that with this value, we got our answer. Now let us see question number 6. This is an important question. This is a cycle, and the cycle is flying from this point to this, and this is in the absence of air resistance is negligible. So this is the case of projectile. Now we need to take care of the velocity. Here at this point, when it is big, here at this point when he was just taking off, and here when he is landing here, at this point we have two velocity. This is towards x-axis and this is towards y-axis. Here also we have two velocity, x-axis and y-axis. Because of two velocity is covering two type of distance. This is vertical distance and this is horizontal distance, but time taken to cover vertical distance and horizontal distance are same. In the same time, it is descending 2 meter downward and it is covering 6 meter forward. Now for the beginning point, at this point the initial velocity towards this y-axis is 0, and the acceleration is acceleration due to gravity. Now let us find the time period. Initial velocity is 0 towards vertical direction, g is 9.8. on using s is equal to ut plus half gt square, we will get our time is 0.6 per second. By the time 0.6 per second, it travels this distance towards this axis, but it travels 6 meter towards this axis. Now we know our distance, now we know our time. Now distance divided by time gives us velocity, that is 9.8 meter per second. That is 9.8 meter per second. 9.8 meter per second is in option choice B. So B is the correct answer for question number C. Now let us see this question, question number 7. In this question, the astronaut on the moon, so it is experiment on moon with no air resistance. So this is also case of projectile, and its initial velocity are the two component. This is the initial velocity towards y-axis, which is called vertical velocity, and this is initial velocity towards x-axis, which is called horizontal velocity. And the acceleration of free fall is 1.6 meter per second. This is the velocity with which it is traveling at the beginning. Now we need to find the velocity after 9 seconds after the throw. After the throw, it will travel to some distance in this path, and at 9 seconds we need to find its velocity. In the case of projectile, we need to know one thing, that the projectiles, this component of velocity always remains same whatever be the position. So if you know the initial horizontal velocity, then we know the final horizontal velocity, because this is always constant here, but this velocity changes. Because of that, resultant velocity also changes. Now this is the initial velocity of the body towards vertical direction. Now we can use this formula in order to find the final velocity after 9 seconds. That is, v is final velocity towards y-axis and 8 is the initial velocity towards y-axis. and it is going up. Because of that, minus at, it is in the surface of moon, and 1.62 is the value of acceleration. So 6.58 is the final velocity of the body after 9 seconds. After 9 seconds, this is 6.58, and this x component is same, 4 meter per second. Now the resultant velocity is obtained by this formula, root under the final velocity towards x-axis plus root under square of final velocity towards x-axis plus root under square of final velocity towards y-axis, which will finally give us 7.7 meter per second. That is in option choice B. So option choice B is the correct answer for question number 7. Now let us see question number 8. In this question, a car is traveling at a constant velocity at a time t is equal to 0, and the driver when the driver saw obstacle, he applies the brake until it hurts, the car stops. Now we need to find the distance travel. As this graph is velocity versus time, the area of velocity versus time graph gives the displacement or distance travel. Here this region is rectangular region. Area of this region is 20 into 0.8, which is 16. Area of this region is triangular, so half into base is the difference between 5 and 0.8, that is 4.2. Half into base into height will give us 42. On adding these two, we will get our answer. Answer for question number 8 is 58 meter. Now let us see question number 9. In this question, a car is stationary at traffic. Because of that, the car is exerting no force here. This is a straight line. When the traffic light goes green, then it is traveling with this constant force. It is traveling with some constant force. At first it was at rest, and then it is moving with constant force. We know that constant force means, if in the relation F is equal to ma, m is always constant. Constant force means acceleration should be constant. Now if we see the graph, in this option choice A, in this region the speed was 0 because it was at rest, and in this region speed is continuously increasing. It means that if we calculate slope from this region, our acceleration will be constant, or if the speed is continuously increasing, then acceleration remains constant, which is the required answer. In other answer choice, acceleration is not constant. So option choice A is the correct answer for question number 9. Now let us see question number 10. In this question, we are throwing a ball from a hotel window. Air resistance is not negligible. Take care of this term. Air resistance is not negligible here. Which graph shows the variation with the time of the acceleration of a ball? Now we know that when a ball is thrown from window and acceleration is not significant, as the ball moves, as the ball's velocity increases, the air resistance also increases, and air resistance also increases. Because of this, air resistance acts upward. Air resistance produces some resistive force. Acceleration, decrease in acceleration becomes non-uniform. Decrease in acceleration becomes non-uniform, which is in fact shown in option choice C. So option choice C is the correct answer. In option choice A, it is directly proportional. In option choice B, it is constant. So option choice C is the right answer for the question number 10. Now let us see question number 11. A car has mass m, and a person need to push a car with a force F in order to give the acceleration A. And this is a car, and if he pulls with force F, it will accelerate with acceleration A. When the person push a car with force 2F, this will be accelerated with 3A. We need to find the resistive force. Resistive force always act backward, and if the given force is able to overcome the resistive force, then the body gets acceleration. Because of that, the given force F minus R must be equal to ma, because this F should be able to overcome the resistive force, and it gives the resultant acceleration. Now let us see this. For the first case, F minus R is giving ma, but in the second case, we are increasing our force. Increasing our force means force will be twice F, and twice F of force is giving thrice A acceleration. This is clearly stated in our question. Now on solving this, on multiplying this expression by 2 and on subtracting with this, we will get our resultant force. This our resistive force. This resistive force will come ma. So ma is in option choice A, option choice A is the correct answer for question number 11. As resistive force remains same in both cases, just we are changing here the force and acceleration, mass and resistive force becomes same as the question is stating it. Now let us move to question number 12. In this question, this P and Q are the this P and R are the force that are acting on the box, and P is the force of the P is the force of the ground on the box. P is the force, it is acting upward, and R is the force force of the box on the ground. So they are equal and opposite, they cancel with each other. If you see our option choice D is the correct answer here. Yours is equal and opposite to the force Q. Gravitational force always comes in this case when the box is in equilibrium, it is in rest. Gravitational force always comes in pair and they cancel with each other. Here this yours is equal to Q. This yours is equal to Q. This is acting upward, this is acting downward. They are the gravitational force on the box and they are cancel with each other. Because of that, ball is there in rest. Now let us see question number 13. In this question, this is initial velocity, this is initial velocity before collision, and this is final velocity after collision. The body, in order to be elastic, the relative velocity of approach, that is u1 minus u2, relative velocity of approach must be equal to relative velocity of separation, that is v2 minus v1. Now if we see this, now let us calculate relative velocity of approach. In option choice D, that will be 5 minus 2. 5 minus 2 is relative velocity of approach, u1 minus u2. Now relative velocity of separation is 6 minus 3. Here is 5 minus 2, 5 minus 2 is 3, and 6 minus 3 is 3. So this is elastic collision. Now let us see option choice C. 3 minus 2 is the relative velocity of approach. 3 minus 2, that is 5. 3 minus 2 is 5. And the relative velocity of separation is 6 minus 1, that is also 5. Because of that, option choice C is also elastic collision. Now let us see option choice B. 3 minus 3 is 6. 3 minus 3, 3 minus 3, this will give us 6, and 6 minus 0 is also 6. Because of that, this is also elastic collision. Now let us see this. 2 minus 5. 2 minus 5 is 7. And if we subtract this b2, minus 2 minus 5 is minus 2 plus minus 2 minus 5 is minus 2 plus 5, that is 3. 7 and 3 are not equal with each other. If the relative velocity of approach is not equal to relative velocity of separation, that is not the elastic collision. So option choice A is the correct answer. Option choice A is the correct answer for question number 13. Now let us move to question number 14. In question number 14, a submarine has a circular window of diameter 0.3 meter. Here it is given a diameter is 0.3 meter. The window experiences a maximum force of 660 kilopascal. Now we need to find the force. This is so simple, so easy one. So pressure is equal to force upon area. Area is given in the term of diameter, so pi d square by 4 gives area. On doing pi d square by 4 and multiplying it with p, we will get our correct answer. We will get our actual answer. The actual answer or correct answer for this question is option choice A. On doing simple mathematical calculation, we will get answer for question number 14. Now let us move to question number 15. In this question, there are 4 beams. These are the 4 beams of same length, and they are experiencing 3 forces. In all cases, 2 forces are acting up and 1 force is acting down. Now which beam has both zero resultant force and zero resultant torque? We can calculate zero resultant force by calculating net upward force and net downward force. If net upward force and net downward force are equal, then the resultant force will be 0. In this, 80 Newton is acting up, but 90 Newton is acting down. So this is not the case of zero resultant force. Here 70 plus 36 will give us 106. This is acting upward. Downward is only one force, it is 106. In this case, resultant force is 0. Here also resultant force is 0. 35 plus 28 is equal to 63. Upward is equal to downward. Here also 70 plus 42 is 112. Upward and downward, these are equal. But in order to find the resultant torque, the first condition is satisfied by the option D. Now let us find the resultant torque. If I consider this point as a reference point, then torque between this here is 70 torque is the force and the perpendicular distance from the given point, perpendicular distance of the force. This is 70 and the distance is 50 plus 30 is 80 centimeter. 80 centimeter means 0.8. On multiplying 70 with 0.8, 70 into 0.8, which gives us 56 Newton meter. So 56 Newton meter is the moment of the foot this point, and if I calculate moment of this force 112, it is at a distance 50 centimeter. So 112 into 0.5, on converting in SI unit, I will again get 56 Newton meter. So moment about 42, clockwise and anti-clockwise moment, upward and downward moment are equal with each other. If the moment are equal, then resulting torque will be also 0. This force was two forces are balanced by this force, and the torque about this, the torque of 70 Newton and the torque of 112 newtons are equal. So option choice D is the correct answer for the question number 15. In other choices, the torque are not equal in option choice B and C, and the force is not equal in the option choice A. Now let us move to question number 16. In this question, this is the air conditioning unit. This is the wall. Here this beam PQ should experience a resultant force. At this point and at this point it is experiencing force. Here this is experiencing force because of this air condition, and here this is experiencing force because of wall. They should be equal and opposite, so that the ball this air condition remains there. For this option choice B is the correct answer. This is acting in right direction, this is acting down, this is acting in upward direction, and this is acting left, and they give the resultant here. So they are balancing with each other. Because of that, net force is experienced towards PQ. Now let us move to question number 17. In this question, a hydro power station uses gravitational power. So if we see this is the mass per unit time. This is the mass per unit time that power station is using, and this is the height, and this power is generated by that hydro station. It means output power is this. Now we need to find the input power. For input power, we have to use this formula. Power input is work done upon time taken, and for here work done is W can be calculated by mgh, and T is already there, but in this question m by T is given. This is m by T, kg per second, mass by T, and this is height, and we know that G is 9.81. Now if we multiply this, we will get our input power. Input power is this, and output power is this. Now power output by power input is 57%. 57% in option choice C. So option choice C is the correct answer for question number 17. Now let us move to question number 18. This is so easy. The work done divided by the heat in is efficiency. So option choice C is the correct answer. This is just a definition. Work done upon heat input. Now let us move to this question. A truck. Here is one truck. This truck is moving in this direction, covering 400 meter distance, and this is at a height 30 meter from ground. Now this gives the potential energy mgh, gravitational potential energy, to this, and this will go down here and uses this potential energy in the form of kinetic energy as well as to overcome the friction. So friction plus kinetic energy in this line will be equal to gravitational potential energy. It lost gravitational potential energy and it gains kinetic energy by overcoming the friction. Now let us see this. The gravitational potential energy here is this mgh, and work done against friction. The frictional force is 250 and the distance is 400. So total work done against friction is this. Now we know that gravitational potential energy is equal to kinetic energy plus work done against friction. So work done against friction is this, gravitational potential energy this. We know the mass of this. Now on solving this, we will get our velocity. our velocity will be 14, and 14 is in option choice A. Option choice A is the correct answer for question number 19. Now let us see question number 20. Which condition should apply for the work done by expanding gas to this? In this question, this is also from the definition of work done on gas. Work done is equal to P into dV. V is here, volume is variable volume, but P is constant. A constant P is written in option choice C, so pressure must be constant in W is equal to P into del V. So option choice C is the correct answer for question number 20. Now let us move to question number 21. In this question, a metal wire is stretched to a breaking point and the force extension graph is plotted. Which graph collectively labeled the elastic region, the plastic region and area represented the work done? If you see this graph, this is the actual work done, and this type of graph is here also. So option choice C and D must be answer. This is the actual work done during this process. But if you see this, carefully, this region is written here plastic region and this region is written here elastic region. But in fact, this region is elastic region and this is a plastic region. Here it is Hooke's law is holding here directly. This is a straight line. Because of that, option choice D is the correct answer here. Option choice A and B are not correct answer because work done is not clearly stated, and this is work done is clear here, but elastic and plastic region are interchanged there. So option choice D is the correct answer for question number 21. Now let us see question number 22. A copper wire hangs vertically from a fixed point. A load is attached to the lower end of the wire producing extension X. The wire obeys Hooke's law. Which signal can gives extension twice X? Now the Young's modulus of copper wire should remain same. Young's modulus is equal to stress upon strain. Stress is force per unit area, and strain is change in length upon original length. If if the extension of wire is twice X, then if extension is increasing, then the stress should also increase. If strain is increasing, then strain should increase. That will obtain by, we know that strain is force upon area. If area is half, then this will be stress will be doubled. Because of that, option choice A is the correct answer for question number 22. In order to remain the Young's modulus, value of Young's modulus as it is, when extension is increased, then cross section area in the, from this option choice, the cross section area is, when cross section area is halved, then Young's modulus remains same. Option choice A is the correct answer for question number 22. Now let us move to question number 23. In this question, we need to remember the value of different wavelength for the different radiation. This is the radio wave 10 to the power 12. This is microwave 10 to the power -2. This is infrared. In this all 10 to the power 4. In the order of 10 to the power 4, it is decreasing from radio wave to gamma wave. This is the correct answer. So option choice A is the correct answer. You need to remember this value. Radio wave 10 to the power 2, microwave 10 to the power -2, and so on. Now question number 24. In this question, we have to use one formula. Wavelength is equal to 2 times L2 minus L1. L2 is the L2 minus L1. L2 is the length of the resonance, the greater length, and L1 is the shorter length. Length of the first resonance is L1. Length of the second resonance is L2. L2 is 0.42. Then L1 is 0.14. On subtracting this, we will get 0.28, and 0.28 into 2 will give us 0.56. That is in option choice D. Option choice D is the correct answer for question number 24. Now let us move to question number 25. In this question, this is the time, this is the distance. So wavelength of this wave is 500 microsecond. The time period of this wave is 500 microsecond, and the velocity is this. Now we need to find which graph represents the movement of the molecule after 0.165 distance travel, 0.165 meter. If we move to 0.165 further. Now let us see this. Here our capital T is 500 microsecond. That is milli micro 10 to the power -6 should be here micro. Now if we multiply in our formula to calculate wavelength is, our formula to calculate Our formula to calculate wavelength is v by f or v into t, because v is equal to f lambda. Now if we do this, our velocity is 330 and this is the time period, so 0.165 meter is the wavelength. It means that the wave is moving, a complete wave is moving to one wavelength. It means that wave will arrive here, wave will travel that distance, so the wave should have same frequency, same amplitude. That is in option choice D. Option choice D is the correct answer, because wave is moving a complete distance, means it is again arriving to the same point, and same amplitude, same frequency, everything will be same. That is in option choice D. So option choice D is the correct answer, because it is traveling 0.165 meter distance, means it is traveling one wavelength. It is traveling one wavelength means it is reaching here, so everything will be same, exactly same to the original graph. Now let us move to question number 26. In this question, this ambulance is approaching to the stationary observer, and if you see our data booklet, there is a formula, and then in that formula, if the source is approaching this observer, we will be using this formula, velocity of source into natural frequency. If you see this, velocity of source is here, natural frequency or frequency of source is here, and this is v minus vs is when ambulance is approaching to the observer, and we know vs is equal to 330, frequency is given 600 Hz, and on doing this, this is moving with 25 meter per second. On doing this, our first frequency will be 649.18. when this moves far from, when the source, this moves far from observer, when this is already overcome this, then it moves here. In this case, this denominator minus will be plus. According to Doppler effect, this is now, after traveling this, the sound should travel here. Sound should always travel towards observer, because of they are changing their direction, opposite direction, the plus sign will come here. Here it was minus sign, because the ambulance was traveling here, and the sound was also going from source to observer, so same direction means opposite sign. Here opposite direction means plus sign, same direction means minus sign, opposite direction means plus sign. So on doing this, we will get our next frequency this. According to question, we need to find the change in frequency of this case when approaching and when leaving. On subtracting this, we will get 91. That 91 is the correct answer for the question number 26. That is in option choice C. Option choice C is the answer for question number 26. Now let us move to question number 27. This is obstacle and this is also obstacle. If the size of obstacle is very less, the diffraction will be more. This is also diffraction, but this is less diffraction. This is not diffracted that much because of the size of obstacle. If the size of obstacle is comparable to the wavelength, then the diffraction will be more. So option choice A is the correct answer. Diagram X and Y both illustrate diffraction, but diffraction is more in Y. Option choice A is the correct answer. Now let us see question number 29. In this question number 29, our formula is this is the D, and this is the angle between first order maxima. So this will be the 30 degree. This will be 30 degree is the angle made by the first maxima. Upward and downward there is also 30 degree. This will be also 30 degree. Now our formula for diffraction is this d sin theta is equal to n lambda. Lambda is wavelength. I have written here wavelength. Length is mistake here. Now d is given this, and theta will be 30 degree. Theta will be from that mean position, and first order is written there. Somewhere here I have seen first order. First order is here. Because of that, I have to write 1 in the place of n. Then on calculating this, we will get our wavelength. And wavelength will come like this, 0.57 into 10⁻⁶, but it is expressed in nanometer. So on doing this or converting this into nanometer, we will get 575 nanometer. That is in option choice C. So option choice C is the correct answer for the question number 29. Option choice C. Thank you very much. All the best for your examinations.